running in an emulator, Sameboy emulator. And I'm going to do a little experiment. So what I want to do is in the beginning of the game, I want to try to get 99 Master Balls. I want to do this without using any sort of cheat codes or looking something up on the internet. Um, all I want to do is to alter the memory in the emulator and see if I can change the item and the amount of something that I have. So let's go into the emulation real fast. I've preloaded something. This is just my game file. So I'm in Pallet Town right now. If you look, oops, Pokedex, scene one. Okay, so I have one Pokemon. It's a Charmander, something like that. I always like Charmander the best. Let's see, an item. I just have a town map. So yeah, right in the beginning of the game, played 15 minutes, no money, nothing like that, right? So the idea is I want to go to the Smart. I'm gonna buy a Pokeball. Um, yeah, so I want to turn this into 99 Master Balls, like right off the bat. So how can I do this without cheat codes? Well, luckily for us, there is a way for Sameboy. It has a developer mode, lets you show the memory right here. So you can see a bunch of values inside there. You can actually see Pokemon Red written right here in hex. But yeah, so basically what we want to do is alter these memory values in one of these places and try to turn these Pokeballs into Master Balls. As you can see, there's some random number generation going on or something right now, and the RAM is actually moving. So even though I'm not doing anything, there's something in the background running on the Game Boy, which is pretty cool. So a useful thing about this Same Boy uh, emulator, it has a debugger, kind of like GDB enabled, and if I type help, it shows a list of commands. So let's see, nothing here seems to fit what we need. So I guess I'll map out the strategy. So what we need to do is go through all of this memory, which is, 64 kilobytes, I think, and figure out the 1 byte, the 2 bytes, which is the item ID and then the item quantity, and we need to figure out which 2 bytes those are, and we need to change them. So how do we go about doing that? So the easiest strategy is right before you buy a Pokeball, right here, is to dump all of this RAM into a file, then buy the Pokeball, and then dump RAM to a file again, and then see what bytes changed, like what addresses changed in between that one action. So that's going to be our goal. This debugger unfortunately doesn't have a dump RAM option. I looked everywhere, I couldn't find it. So luckily it's open source, so I guess we're just gonna have to like write it ourselves today. So I'm gonna close out of this for now and just open my terminal. I'm gonna go into my developer folder and let's look up the repo for SameBoy. Sorry, I'm just closing a few windows. Okay, so let's look up the GitHub repo. So SameBoy GitHub. I have it here for us. That way it won't take too long. Okay, code. So we're gonna just clone this Git repo. So git clone SameBoy. Cool. So we got SameBoy going, downloading right now. Okay, so after it's downloaded, go into here. Typically with these C-based projects, I like to just make them like right off the bat. While I'm waiting on that, I'm gonna open up Emacs. Okay, we're gonna go into a project. Let's see. Let's try and find a project. So developer, SameBoy. Who cares? We'll just open up one of these MD files. Okay, cool. So done compiling, but it looks like we have 3 errors. It's saying we're trying to convert from an unsigned long to a double, uh, and it changes the value. So let's see, float right here, integer max. So yeah, it seems like they're comparing a float to an integer or a long, and it'll cast it to a double so that the types both match. Looking here, looks like it's just literally rounding it by 1. Uh, Probably not a good thing, but who cares? So I can't implicitly convert it. Let's see if we can just explicitly convert this. This is this file. This is this error here. Okay, so it's all in the same file, it looks like. So yeah, let's just fire up Emacs, HF representer text view.m and see if we can't fix that. Uh, presenter text view dot m. I think I saw line 130 was the first one. Okay, so let's just cast that to a double, double, okay, double, double. There's one more line. I forgot which one it was. Do 1439. Okay, so cast these to a double. Okay, let's remake this. See if we get luckier. Okay, so while we're doing that, I guess I can open the emulator again. So I'm gonna open just the ROM to here. Okay, so if I go into list of help commands, oh cool, so it looks like it built. So if I go into the list of help commands, um, let's see, it has continue next. We just kind of want to search the code base and figure out like where to find these things. So if I search the code base for examine, okay, so two places. One looks like a function declaration. The other looks like a list of something. So the list is probably more promising. So I'll go to that. Okay, so look at this. There's a list of commands. Um, looks like a name, something, function pointer, help string or something. See if it matches the same way. Examines values at address. Where is that? Examine. Yeah, so there it is right there. Cool. So I think ours is going to be simple. It's just going to be like this registers probably. I'm going to make a command called like memdump, just add it in. I don't really know what this one is. Let me go back. Let's see what this debugger command T is. Okay, so you got a command length. I don't know what min length is. Implementation, probably function pointer, help string. Okay, so I mean, who cares? I don't know what the min length does, but it doesn't matter. We're gonna make a function called memdump, and we're gonna have it dump dump RAM into a file. Cool. Okay, so we got that. How do we actually implement this memdump function? Let's take a look at some of these other functions. Static bool, it has this format. Let's see. Static bool. Yeah, so it looks like they're all static bools, and they all have to have these sort of arguments, same amount of arguments, which makes sense because, yeah, it's just the way the project's structured. Oh, I hate when it auto formats it like this. Come on. Okay, so we got the demand right here, command right here. Let's see. First, we're going to just return true. Okay, so we need a file name that we're going to dump it to. Oh, and let me change this to memdump. So name of this is going to be called memdump. File name, and we're going to just call it memdump.xyz. The extension doesn't matter. It's just easier to find if you do an XYZ or something, some weird extension. Okay, so now I'm just going to print something to the screen just so I can test if this is actually working. I see this GB log right here, so I'm assuming that's how you log stuff to the screen. So it takes in a Game Boy object, and we're just going to do the file name. So let's see, file name, nice. Well, we don't just want the file name. I'll just say dumping RAM to the file name. Cool. So we have this. We should remake. Nice. We gotta find where the same boy is located. I don't want to use this version of same boy because this is the pre-built one. I want to use the build version. So if I do a find, I think it'll be something like sameboy.app. Oh, cool. So it's in bin, build/bin. So we'll go here. There we go. So we're gonna open sameboy.app. I'm gonna load up this Pokemon Red, and if we go here, let's see, go to help, we should have our, should pop up. Oh wow, look at that. We have our memdump. Nice, cool. So that actually worked. That's nice. Okay, so what I'm going to do is load up my emulator state, and that's weird. Didn't seem to work. Open up the emulator. Load slot 1. Okay, cool. So here we are, right by the mart. Okay, so I'm gonna buy something. Pokeball. Okay, so I want to dump the memory just before I buy it. Now the question is like, how many Pokeballs should I buy? If I buy just one, it's gonna be very hard to track down in the hex. So good option I would say would either be 11 or 7. I think 7's easier. I don't want to do the hex search for the yeah conversions. So we'll buy 7 Pokeballs and then we're gonna search RAM for the number 7 after we dump the memory. So okay, so right before we buy it, the step before we buy it, now we're gonna dump the memory. So I'm gonna open up the debugger and I'm gonna say dump memory. Oh, memdump, sorry. Okay, let's open this up. Okay, so it didn't actually dump the memory because we haven't implemented the actual function yet, but you did see that we got our message saying dumping RAM to memory. Okay, cool. So now we now we just need to implement this function. So it'd be nice if we could read memory somehow. So let's search. Yeah, so there is a function called gb read memory. Let's see what this is defined. It's defined in memory.h. So is there a memory.c? gb read memory. Um, cool. So there's this read memory function. I don't really know how it does what it does, but I'm assuming it just reads memory and gives you back a value. So we're just going to change this to a dump memory function. So we're going to define that. And we don't really want an address. We want a file name. So we're just going to dump memory to this file. Let's see. Okay. So first thing we're going to do is open the file. I think fopen is probably, because we're going to do bytes, read bytes. Fopen is the best. Let's do the man page. Yeah, so it's just a path. Okay, file star file equals fopen, and then we're going to pass it the file name, and we want to write bytes to the file. Okay, and just to be, good citizens, we're going to close this file after we're done with it. All right, so basically we want to just loop through the memory, read some byte, and then write that to a file. So let me see. Memory locations in Game Boy. If you go to the memory map, okay, so there's 64 kilobytes. So 0xFFFFF is the highest flag we can go to, the highest memory address we can go to. So I'm going to say for uh, it needs a uint16 type down here, right? So we're gonna have an address, and it's gonna be equal to 0x000. ADR is less than or equal to 0xFFFF. ADR, well, we'll just do less than. I know the internet, we don't care about that interrupt flag at the end. Address plus plus, there. So we're gonna say data. So we're gonna say what does this return? uint8 type. Data equals GB read memory, and it's gonna read the Game Boy, and it's gonna read the address. We're gonna pass in the Game Boy object, read the address, and then what we want to do is we're gonna do fwrite. Here we need a void star. Let me go into man page for fwrite. I forgot how this works. Okay, a size in items and a file. Okay, so we need a pointer to this data. The size is going to be size of uint8, so we're going to write 1 byte. We're going to write one of these, and we're going to write it to file. Cool. All right, so that's our dump memory function. Very simple, just a for loop through memory. I'm going to define it here so that it's visible to the other program, to the other file. What is it taking? A constant char star file name. Cool. So we have our function. All that's left is to hook it up to our debugger code. What is it? Dump. Memdump. Good. That's what it's called. Yeah. So we're just going to dump the memory right here. And we're going to pass in the Game Boy object. And we're going to pass in the file name. And there we go. We should be good to go. Let's rebuild this. So we're gonna make, hopefully this works. Seems like we've changed a lot of object files by doing this, but yeah, hopefully it compiles quickly. I can actually close out of this and I'll have to reopen it. Okay, cool. So it's there. Let me see. Close out of this. Open up same boy. Go here. Okay. So let's load up our emulator. We're gonna go into the mart. Okay. So right before I buy 7 Pokeballs, I am going to mem dump. So let's just make sure it's still there. Yep. All right. So mem dump, and we get a program crash. Cool. So, that's weird. Okay. So I guess what we'll do here is we'll go to same boy. We'll LDB this and see what's going on. So here, what I'm gonna do is I'm gonna break mem dump. Okay. Gonna run it. Okay, so same boy is launched. We're gonna go here. A lot of weird stuff going on, but who cares? Load state 1. Okay, let's go into the mart. Okay, let's buy 7. Try to buy 7 Pokeballs. Okay, let's mim dump. Here we go. That looks good. Step inside here. Oh, I didn't mean to do that. Okay, who cares? Okay, dump memory. That's where we want to go. Okay, I don't want to get trapped in the for loop, so I'm just gonna break 761. Well, that's weird. Looks like we looped through the entire file and everything seems to be okay. So, it's weird. Alright, let's resume. ls. Oh, look, we have our mimdump.xyz. So, for whatever reason, it's working inside LLDB, but not inside of when I run it regularly, which is weird, but don't really care for our purposes. So, I'm just going to rename this to before purchase so that we have a reference point. Clear. Okay, so we're continuing. I'm going to exit out of this, see if this still works. And yeah, this time same as last time. So what we did was we dumped the RAM prior to making the purchase. Now we're going to actually make the purchase. Okay. Let's see if we have a Pokeball. Oops. Item. 7 Pokeballs, right? Okay, we're going to save this state. And then now we actually want to dump the memory. Probably shouldn't have walked around so much. Oh, mem dump. Okay, so hit our GDB, see if everything goes through. All right, so we have a before purchase file. Now we have a mem dump. I'm just going to change this to after purchase, so it's easier. So right now we have the memory before the purchase, the memory after purchase. Let's just check them out real fast to make sure they're legitimate. Oh, nice, beautiful hex dump. Looks fine. After purchase looks fine as well. Cool. So this is probably frozen right here. I don't know why it kind of freezes when I do this command, but who cares? We got the memory we wanted. Next thing I do is open up like Hexfiend, which is like a hex editor, and just check out these 2 files. So we have a before purchase and after purchase, right? Open these in the hex editor. Kind of hurts the eyes. Oh, let's see. Open these in a hex editor. Uh, before purchase, after purchase. Here we go. Now we want to compare them. There's probably a shortcut to do that, but that's okay. All right, let's compare these 2 files. Oof. If you see on the left, this is just the changes in the RAM. So a lot of changes. Definitely something we can't really parse out by just looking at it, right? So we're probably gonna have to enlist the help of Python or some other programming language to loop through this. But before we do that, we actually need one more emulation memory dump. And basically, there's a lot of changes between these 2 files. I don't want to manually have to test each one of them to see which one's a false positive and which one isn't. So some of these changes are like player location, random number generators. So what we want to do is kind of eliminate these false positives. So the way we do that is we're gonna do one more memory dump. So I'm just gonna walk around and talk to people, maybe battle a Pokemon, change the map area, and see if I can root out some of these false positives. Oh, cool. Nidoran level 4 is pretty good. Okay, critical hit. Nice. Okay, good, good, good. Okay, good. Knock them out. Oh, grew to level 7. That's good. So basically just simulate a bunch of events happening in the game for one more memory dump so we can have like a cross reference to see which memory changes are static and which aren't. So basically the number of items I have should never change. So even between this next memory dump and the second memory dump, like it should stay the same. You'll see what I mean when I write the code. So mem dump, where's GDB? Oh yeah, block right there. Okay, that's working. Let's make sure. Oh look, we have a before purchase, after purchase, and a memdump.xyz. Cool. So let's move this memdump.xyz to I don't know, normal events. Who cares what it's called? XXD normal events. Cool. So looks good. Just gonna close out of this for now. Oh, but well, it doesn't matter. Okay, cool. So let me clear this. Gonna list the help of Python. I don't know much Python, but you know, it is what it is. Uh, it's easier than writing C for our purposes. So open, dang it. So what we're gonna do is we're gonna open that first file. What was it called? Before purchase, and we're gonna do read bytes, and we're gonna just read all these bytes, and then we're gonna open a file after purchase, and we're just gonna read all these bytes, and then I think that thing was called normal events. That was a bad name. Yeah. C is equal to normal events. A, B, C. Link to A, link to B, link to C. Cool. So A, B, and C, all the same link. That checks out well. Okay, so what we want to do is we want to loop through all the addresses. So I equals 0, while I is less than 0x f, 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 f. Okay, so if a to the I does not equal b to the I, right? So when you buy an item, obviously a and wherever the item's located, that byte's going to change, right? Uh, okay, so for C, which is the just doing random events, we expect that even if we do a bunch of random events, the number of items we have or the ID of the item we have is not going to change, right? So yeah, it needs to stay the same between those two memory dumps. And then we also know that B to the I, we bought 7 Pokeballs, so we actually want it to equal 7, right? And it's going to be in this like byte format. It's kind of weird. Okay. Oh, it's supposed to be an if statement. Okay, cool. And then we want to print, how the heck do you print a hex string in Python? Python 2, print hex, Python, I always have to, yeah, look this up. Okay, something like this, right? Nice. Okay, so we're gonna print that. And then for now, we're gonna just increment I by 1. And let's see what memory locations come up. Cool. So we have these 1, 2, 3, 4, 5. Yeah, so we have a few locations. Um, let's see. So I'm gonna open up Same Boy. I'm gonna Pokemon Red. Cool. Uh, load state. I think slot 2 is after we've bought the Pokeballs, right? Cool. Let's go into this memory viewer. Where is it? Develop, show memory. All right, so let's just check all these out. Let's go to 4290. 4290. Well, that was a false positive. It doesn't look like I don't see a 7 here. So that doesn't look right. AF1. That also doesn't look right. That's a 23. Okay, so that looks like a false positive. 6C56. Okay, that's also being changed. So that's a 26 now. That's weird. Uh, okay. This one, CF97. Okay, that is a 7. That is true. And this is a 7. Could that be it? It's kind of weird that they're both 7s though. Okay, so what if I make this a 6? Okay, let's go into our items. Nope, doesn't look like anything changed. So, oh, and that's already been overwritten back to a 7 somehow. So that wasn't the right one. All right, so D321. Okay, let's see. Well, this looks promising. So we have 4, 7, and this FF looks like some kind of delimiter, maybe. So maybe it's the end of your items list. Let's give it a shot. So I'm gonna take the 7, and we're gonna turn it into a 4. Okay. Open it up. Open up our thing. See. Hey, look at that. We have found the address. So it says D321. Nice. Okay. Let's see if we can make it 99 Pokeballs. So 99 in hex is 6, 3. So 6 times 16 is 96, plus 3 is 99. So 6, 3. All right, let's try it out. Open the items. Look at that, 99 Pokeballs. Cool. Almost there. So if this is the quantity right here, that's what I'm assuming. I think FS is probably like the end of uh, the items array. So it's like a delimiter to mark array in. So my guess is like this could be the item ID. Let me just try. So I'm gonna just decrement it by 1, see what happens. So from 4 to 3, and look at that. We have a great ball. And let's see, 2. Okay. I mean, if the last one was a great ball, then hopefully Ultra Ball. Oops, I think I hit the A button right here. What do we have? 63. Cool. Okay, let's try 1. Hopefully this will get us the Master Ball. There we go. Item. Yeah, we got 99 Master Balls. I do see a town map, right? So maybe this is like how many items we have. 2 items. And we have a town map. Okay, let's try and change the town map to a Pokeball just to see what happens. Yeah, nice. Okay, let's see if we can like add the town map back by updating this. So the town map was 05 and then 01, right? So we had 1 of the town map followed by a delimiter. Cool. So if we open this, oh nice, we have the town map, but look, we can't scroll past it, so I can't go to the cancel. So I think this thing right here is probably the number of items we have. So let me update that to 3, see if that fixes the scroll. Look at that. Works perfectly. And let's just give ourselves like, let's just pick a random number. So I'm gonna update this to 4. We'll play like a little lottery. I'm just gonna do hex 26. Maybe it has that many items, I don't know. And we're gonna have 10. So 10 of those. Oh, we don't want AF. We want 0A. And we want this to be the delimiter. And let's just see. Okay, 10 carbos. I think that boosts speed, right? Cool. So yeah, there you have it. We have successfully hacked the Pokemon Red, fulfilled a childhood dream of mine. We have 99 Master Balls, right? And let's see. Let's just try it out real fast. Make sure nothing's corrupted. Nidoran, a waste of a Master Ball, but let's just throw it. And look at that. So there we go. And we know it all exists in D321. So if we ever want to, if we run out of master balls somehow, you'd have to be terrible for that to happen. But if you ever wanted to replenish it, you can. Can I use the town map? Yep, you can use it. Cool. So, yep, that is it.